Hi guys, welcome to video number 7 of the forces series. In today's video, we're going to talk about forces in equilibrium, what it means when an object is said to be in equilibrium, and few other things. It's likely the calculations in this very video is going to be very minimum. We're going to try our best not to do a lot of calculation just to understand the concept of forces in equilibrium, and maybe in subsequent videos we go into the calculations. If this is your very first time joining the channel, please take a time to subscribe to the channel and also press on the notification bell so that you receive notifications when I post new materials or videos. Okay, so let's just dive straight into equilibrium. So we're going to talk about forces in equilibrium. Well, for a layman perspective, I think just by reading the word equilibrium, it sounds like equal. I don't know about you, but like to me, something something that is kind of equal. So let's take a particle. Let's take this one to be particle, or should I say? Let me just get a box instead. Let me get a box first. Floor. So there's a floor. Let me get a box on this. So this and this and this. Okay. So some stickmen. Let's say this me. Obviously, you've not seen me before, so oh, that doesn't look like me. So there's me. I'm trying to pull this box with a force of magnitude of, let's say, 10 newtons, 10 newtons, and this a friend of mine also trying to pull this box towards the side. I don't know how he's going to do it, but yeah. And it turns out that it's also pulling the box, sorry, with a magnitude of 10 newtons. What do you think the box is going to do? Do you think the box is going to move? I strongly disagree that this box is going to move because from what we've learned so far, we're saying that an object is going to move if and only if there is a leftover force, there is a resultant force. Now you can see that since both of us are pulling using the same amount of force, this object is not going to move. There will be no leftover force. So when an object is said to be in equilibrium, it means that the object is not moving. In some books, you come across the fact that they'll tell you that when an object is in equilibrium, it means that the forces cancel out each other. Well, this is not entirely true. There can be cases where the forces will balance off each other, but the objects will still move. That's where mechanics 2 will come in, and we'll talk about movement of forces. So the main definition of forces in equilibrium is that the forces should cancel out each other, and the total moment about the object on the object should be 0. So the clockwise moment should also be equal to anti-clockwise moment. But like I said, this is just mechanics 1. I'm not really going to go into details. So we just leave it there that when a force is in equilibrium, the forces balance off each other. So forces to the top will be equal to forces to the bottom. Forces to the right should be equal to forces to the left. So basically, that is what we're going to talk about throughout. So we know from resultant force that to find the resultant in x, this forces to the right minus forces to the left. Now when an object is in equilibrium, it means that it has got no resultant in either direction. So resultant in y also is forces to the top minus forces to the bottom. It has got no resultant in either direction. So what I can say is that resultant in the x direction is actually going to be equal to 0 because there is no movement in the x direction, and resultant in the y direction is also going to be equal to 0. There will be no movement in the y direction. Later on, we look at the other forces acting on this particle. Let me just put it there. There can be a weight force acting downwards, and there will be a normal reaction force acting upwards. So we're going to talk about these kind of forces later. Back to what we're talking about. So we're saying that resultant in the x direction is equal to 0. If that's the case, I can write this one as 0 is equal to forces to the right minus forces to the left. Doing manipulations, I can come to the conclusion that forces to the right should be equal to forces to the left. So whichever way you send the arrows, you end up getting something of this nature. Similarly, with the y direction, resultant in y is equal to 0. This implies that 0 is equal to forces to the top minus forces to the bottom. And if you do the manipulations, you end up getting forces to the top to be equal to forces to the bottom. So when I tell you an object is in the equilibrium, these are the key things I want you to remember. So the forces balance off each other. And for your level, for the A level mechanics one, we're not really talking about moments of forces. So I'm not going to add the other definition where the moment should be also equal. So basically, the resultant in the x direction is equal to 0 and the resultant in the y direction is equal to 0. You can stick to this one. You can stick to this fact so that you don't get yourself confused. If you are really okay with the resultant force, just know that resultant in x is equal to um, forces to the right minus forces to the left. But when the forces are in equilibrium, the resultant is equal to 0. And you do the substitution and you are good to go. Or if you are a person that you don't have issues adding on to what you already know, you can say that when forces are in equilibrium, forces to the right will be equal to forces to the left, and forces to the top should balance off forces to the bottom. So that is just the concept of resultant force. And I think in our next video, we're just going to talk about how to use this in um, other calculations. Uh, thank you for watching. Please don't forget to subscribe. Bye for now.